Hello, how you all doing today? This fine Thursday. Hey Naruto, Amit ji, Divya, hi. Mayuk, absolutely, why not? Chemi's option does depend on pressure, yes, for sure. See, adsorption, acha, by the way, can you guys hear me and see me clearly? Mayuk, सीधे fastest finger first already on the first question. Good to see that. Just give me a hi, hello, अगर मेरी आवाज़ ठीक से आ रही है, you are able to hear me and see me clearly. We'll start off right away. I'll address Mayuk ji's सवाल. Can you just move me to the other side? I'll first also talk about the क्या बोलते हैं homework questions. Thank you for answering those. Hey, can you guys? Oh, all right, you can see me. Okay, great, Mayuk. Does Chemi's option? Hello. Okay, all good. ठीक है. There's a small lag between what you say and what I hear, but that's all right. No tension. Yeah, definitely it does. Just check out last session if you want, or read up a little bit more about Chemi's option. हम लोगों ने जो isobars किए थे, right? Things dependent on temperature that showed that, and isotherms are valid for both Chemi's option and Phys's option. ठीक है. अगर n एक हो जाएगा तब Chemi's option होगा. It's monolayer. That's the main thing, right? And we don't study Chemi's option in detail because it's a little bit complicated. ठीक है, at our level. Hey Bhumi, hello. ठीक है. Homework questions. Thank you so much for giving me the answers. All of you who commented there were right. किसने किसने comment किया? How do I go to the last session? Just tell me now who all commented. I remember Naruto had commented. I also remember Mayuk had commented, right? On that. So thanks for that. This answer is this guy here. ये last वाला this तरफ आ गया अभी. हाँ ये वाला इसमें नहीं not ये वाला comment नहीं अभी पुराना session का, but that's okay. That's okay. We can go to the end. Yeah. This is the right answer for this. This is not related to adsorption. ठीक है? Because you remember जब हमने x by m और p के versus किया था, then the graph looked like this. This was very similar to PV equal to constant, right? तो यानी कि x by m into p होता शायद, but not equal to p into t. इसकी हम लोग theory में detail में नहीं जाएंगे, but this is the right answer and this was asked in AIPMT in 2011. Good job on answering this. The other one was not correct regarding absorption of gas on surface of solid. हाँ यार ये भी straight forward ही था, right? अगर मैं temperature बढ़ाऊंगा तो absorption will not increase continuously. Increase होके फिर घट जाएगा, है ना? This was the nature of the graph. So good job. नहीं कल क्लास नहीं हुई भूमि जी. I am right now I'm teaching on Monday, Tuesday and then Thursday, Friday. अभी ऐसा time लिखें. So we're just figuring out. All of us are new on this channel, right? So we're figuring out the best time that works for everybody. So that's what my sessions are going to be this week, and we'll figure out next week. अच्छा, by the way, Langmuir isotherm के बारे में कोई मेरे से पूछ रहा था, right? Last time. So I thought कि यार मैं यहाँ पे पढ़ा दूंगा, but then it will go a little bit off topic. So I'll tell you how to find it on the Akash Bios app very quickly. ठीक है? This is the app. This is where the app looks. All you have got to do is, let me just change the pen here so I can click. हाँ, you have to go to this search button यहाँ पे ऊपर. Click on that and then just type it out Langmuir isotherm. ठीक है? It's as simple as that. It's as good as a Google search. Video pops up, play it, and that's Siddesh. I recorded this video with him. I was in the studio. Anyway, this is बहुत पुरानी बात है 2016 की. खैर. And that's the Langmuir का आप देख सकते हो. Also, मेरे से कुछ लोग पूछ रहे हैं practice के लिए आप sheets देंगे नहीं देंगे. If you want to watch more videos on practice, you see there's a NEET analysis. There's focus on JEE NEET. There's a separate practice set by Nitika and Kartikeya on NEET and JEE as well. If you want to check those out, you can check those out. ठीक है? App पे है, आप आराम से देखिएगा. Okay, let's start with today's session. हाँ, hello ईश्वरी जी, क्या करने वाला है? काफी जैम पैक सेशन होने वाला है. देखिए, now more than ever, please मेरे दोस्तों, NCERT पढ़ना बहुत जरूरी है. एक लाइन NCERT की हम लोग ने एक स्लाइड पे डाली है, so you can imagine हम लोग सारी लाइन इस पे कवर नहीं कर रहे हैं because there's a lot of theory and there are a lot of examples that NCERT has given, right? We'll try and what I'm going to do is I'm going to try and give you an idea as to इस example का meaning क्या है and give you the concept behind it. After point you'll have to make flashcards and try and remember it, okay? Half of this session is going to be about some sort of theory that we can kind of draw some nice graphs around it. उसके बाद यार बहुत डेंस थ्योरी है, एक के बाद एक एग्जांपल आता रहेगा, ठीक है? उसके लिए यू बेस्ट रीड एनसीईआरटी. यू कैन अटेंड दिस सेशन, गो थ्रू थिंग्स. बता दो कौन सा वाला पार्ट. यहां से ना, लेट मी जस्ट शो यू दिस हाईलाइट. टिल हियर वी आर गुड, वी हैव सम ग्राफ्स, वी हैव. आफ्टर दिस ना, मोस्ट ऑफ दिस इज वेरी डेंस. थोड़ा सा फिर एब्जॉर्प्शन थ्योरी में यू हैव अ लिटिल बिट ऑफ कॉन्सेप्चुअल स्टफ एंड देन अ लॉट ऑफ इट इज जस्ट हेवी थ्योरी. सो वी हैव सम रियली नाइस ग्राफ्स कमिंग अप, सम रियली नाइस एनिमेशंस एंड स्टफ. सो स्टिक अराउंड. एंड बट या, आई एम गिविंग यू अ डिस्क्लेमर. NCERT भाई इसमें पढ़नी पड़ेगी, ठीक है? Surface chemistry now is going to get a little heavy theory wise. All right, cool. So we are on the third session today. We'll do 3 more and we'll wrap it up in that. So the small thing that you need to remember from last session, बहुत छोटी सी चीज ये है कि ये हमारा एक्सप्रेशन था, राइट? x by m equal to kp power 1 by n. और मैं लॉग लेता हूं दोनों तरफ तो ये निकल जाता है। इस वाले का ये वाला ग्राफ हो गया, इस वाले का ये वाला ग्राफ हो गया। अब मैं इस ग्राफ को थोड़ा डाइसेक्ट करने वाला हूं। कौन सा ग्राफ? द वन दैट्स ऑन माय या दिस साइड, वेट होल्ड ऑन, राइट हियर। मैं नॉर्मली उस तरफ होता हूं स्क्रीन के, सो नाउ आई गेट कंफ्यूज विद लेफ्ट राइट। ये वाले ग्राफ को हम लोग डाइसेक्ट करने वाले हैं, ठीक है। एंड देन यू विल सी दैट वी टॉक अबाउट सॉल्यूशंस, फिर हमको सिमिलर ग्राफ दिखेंगे। सो लेट्स फर्स्ट आइडेंटिफाई द सेम सेटिंग। इसलिए मैंने बोला प्रीवियस सेशन था आपको छोटी सी ये लेनी है कि हम लोग एब्जॉर्प्शन आइसोथर्म की बात कर रहे हैं एट डिफरेंट प्रेशर रेंजेस, ठीक है। तो यानी कि x बाय m इक्वल टू के पी पावर 1 बाय n। अगर n 1 होगा तो x बाय m क्या होगा? विल बी इक्वल टू के पी। सिंपल, बहुत बेसिक मैथ्स मैं कर रहा हूं, बट अगर ये हुआ तो दिस इज वेरी सिमिलर टू y इक्वल टू mx, यानी कि ग्राफ कैसा होगा? एक स्ट्रेट लाइन थ्रू द ओरिजिन, करेक्ट। तो वही हम देखते हैं फॉर सम प्रेशर्स। फॉर सम प्रेशर्स x बाय m इज लीनियरली डिपेंडेंट ऑन प्रेशर। देखिए यहां पे ये स्ट्रेट लाइन आ गई, ठीक है। ऑल गुड सो फार? विदाउट इंटरसेप्ट? Yes, pro boy. Hey, pro boy, change your name and your photo. Yeah, good job. Without intercept. mx plus c, c नहीं यहाँ पे। अब ये वाला पार्ट मुझे बहुत अच्छा लगा पढ़ाने में। ग्राफ जहाँ पे हो ना, आई एम हैप्पी बिकॉज आई कैन एक्सप्लेन थिंग्स टू। जब बहुत ज्यादा थियरी आती है ना, तब आपको फ्लैश कार्ड बना के पढ़ाना ही पड़ेगा। खैर, नाउ जब 1 बाय n इज बिटवीन 0 to 1, रिमेंबर n इज ग्रेटर देन 1 2 3 कुछ भी हो सकता है ना, ग्रेटर देन इक्वल टू। नॉर्मली यही था, मैंने लास्ट सेशन को बताया था। तो n की वैल्यू जब इससे बढ़ जाती है तो 1 बाय n की वैल्यू विल बी बिटवीन 0 and 1। जब 1 बाय n की वैल्यू 0 n के बीच में है तो हमारे पास यही एक्सप्रेशन आता है। और ये एक्सप्रेशन थोड़ा सा कॉम्प्लिकेटेड है इन द सेंस कि अगर मैं इसको ग्राफ को देखूंगा तो देखिए ये कर्व हो जाता है, ठीक है। दिस इज दैट पर्सन, दैट पोर्शन ऑफ द ग्राफ। कर्व क्यों है? क्योंकि अभी n की वैल्यू बदल गई। तो यू मे बी लाइक, अच्छा तो प्रेशर बदलने से भी n की वैल्यू बदलती है। लास्ट सेशन में somebody asked me what does K mean? And I gave you a very philosophical answer. It is something, it's empirical and all that, because yes, that's exactly what it is. Yeah, nobody understands how it works. We have hundreds of years of theory on this, but we accept it. ठीक है, काम करता है, इसको let's use it. Okay, the details are less than 45 degrees. That's a very interesting viewpoint. Why is it less than 45 degrees? Mayuk, you want to tell us? यहाँ पे it's going to be a curve, ठीक है, because it is Kp power 1 by n. जब आप बोल रहे थे वो जो सीधा वाला था वो 45 डिग्री, दो लोग आप बोल रहे हो। लेट मी ट्राई एंड अंडरस्टैंड दैट। स्लोप लेस देन 45 डिग्रीज, लेट मी अंडरस्टैंड दैट वन। 45 डिग्रीज मतलब कि 1, राइट? आई विल थिंक अबाउट दैट एज टू व्हाई इट इज लेस देन 45। मैं एग्जैक्टली समझ नहीं पा रहा हूं क्यों, बट टेल मी मोर। आई विल थिंक अबाउट दैट एंड टेल मी मोर व्हाट योर आइडियाज देयर। ओके, खैर, दैट वाज द मिडिल पार्ट ऑफ द सेक्शन। आफ्टर अ पॉइंट आई टोल्ड यू कि यार सैचुरेशन प्रेशर आ जाता है, उसके बाद इट डजंट मैटर हाउ मच आई इंक्रीज द प्रेशर, एब्जॉर्प्शन नहीं होता है। मतलब n is infinite. I mean, that has no sense. n की कोई मीनिंग नहीं है, बट मैथमेटिकली मैं बोल सकता हूं कि n is infinite, राइट? तभी तो 1 by n 0 होगा। तो ठीक है, मैंने मैथमेटिकल आइडिया ले लिया। तो यहाँ पे x by m will be equal to k, and this is very similar to that graph that we have ना, PV versus P, मतलब आइडियल गैस के लिए कांस्टेंट लाइन होता है। तो that's what we are doing. So x by m versus P will be a straight line for that section of the graph इसके बाद, right? So I keep increasing the pressure and after a point in time ये flat line हो जाता है, that is saturation. तो ये 3 पोर्शन थे of the whole Freundlich isotherm, and with that we are more or less done with this part. Okay, छोटा सा पार्ट था, but I thought last time थोड़ा heavy हो गया था, but I thought I'll just teach this properly here. Any doubts here, my friend? You're right. 1 by n slope equal to 1 tan 45, right? वो जो आप बोल रहे हैं वो पहले बार था, तो एक से कम क्यों होगा आपने बोला स्लोप? I understand what you're saying. अच्छा, अब मुझे समझ में आया। मतलब आप बोल रहे हैं कि ये जो भी होगा, all of these slopes at any point in time will be less than 1. ठीक है, मान गया। बहुत अच्छी बात, बहुत अच्छी बात, बिल्कुल समझ गया। Why I was saying कि मुझे समझ में नहीं आ रहा है, क्योंकि the slope is not constant, right? Slope keeps changing, क्योंकि मेरे पास एक्सप्रेशन है x by m पार क्या था इधर, देखिए kp पार 1 by n, तो इट इज नॉट अ कांस्टेंट स्लोप। ठीक है, एनीवे लॉग लोगे तो सीधा हो जाएगा। यू आर राइट, थैंक यू। या मीडियम प्रेशर वाला रीजन, आई गॉट इट। तो इसके सबसे बड़े ड्रॉबैक्स क्या है ऑफ दिस होल Freundlich isotherm, राइट? इट्स पॉजिटिव थिंग्स आर दैट इट वर्क्स, बट द नेगेटिव थिंग इज कि यार आफ्टर पॉइंट इन टाइम इट जस्ट सेज कि इट जस्ट फेल्स। हाई प्रेशर पे इट्स सेइंग कि भाई सैचुरेट हो जाता है। एंड दिस एप्लीकेबल जब एक सिंगल मॉलिक्यूलर लेयर बन जाए तब ठीक है, बट अगर मल्टी लेयर होता है देन दिस नॉट इन योर सिलेबस एनीथिंग, देन समथिंग लाइक दिस हैपेंस। यू नो, यू मे अस्यूम कि इट मे स्टॉप हियर, बट फिर ऊपर एक और, फिर ऊपर एक और, फिर ऊपर एक और आ जाता है। नॉट इन योर सिलेबस, डोंट नॉट वरी अबाउट इट, ये सब इंजीनियरिंग में पढ़ाया जाता है, बट अगर आप जानना चाहे तो यू कैन रीड अप मोर ऑन दैट। खैर, एक छोटा सा सवाल लेते हैं AIPMT का, द बिग वन। In Freundlich isotherm, the value of 1 by n is Which of these four? Between 0 to 1 in all cases, between 2 and 4 in all cases, 1 in the case of physical adsorption, 1 in the case of chemisorption. अरे मयूख सवाल पढ़ने से पहले ही आंसर दे दिया. ठीक है, I'm going to chalk 1 up to Mayuk. What do the rest of you think? Hello Tanu ji. Sorry if I missed your comments. I'm just going through them quickly. Hey Amit. Okay, cool. Option A lock किया जाए. Great. So two of you are saying option A. I'm going to have to go with that one. This is a straightforward. मैंने just अभी आपको बोला कि between 0 and 1 all cases है. ये 1 in case of resorption हो सकता है, 1 in case of chemisorption भी हो सकता है, but it's always between 0 and 1. ठीक है, all cases में. That's a little complicated because I understand कि you may want to mark the other ones, but since this is from AIPMT and this was the right answer given there, it's not ambiguous and that is the right one. ठीक है, अगला सवाल देखते हैं. एक और छोटा सा सवाल before we move on to the next part of theory. A plot of log x by m versus log p for the adsorption of a gas on solid gives a straight line with slope equal to काफी direct है, but hey, just to nail the point home, ठीक है, to everyone watching live and to folks who watch it later as well, all you've got to do is remember this one form of the equation, right? आप इसको याद करिए and then after that log निकालना है, कुछ भी करना है, इस पे लगाए करिए, कुछ भी लगा करिए, ठीक है? Mayuk says option D. I'm going to agree with Mayuk and move on. This theory, this session is quite jam-packed, right? And unless there's a tricky thing, I'm going to keep going. If you want me to stop, slow down, please let me know. Yeah, option D is correct. वही मैंने यहाँ पे बोला था ना कि अब log यहाँ पे लोगे दोनों तरफ, तो log x by m will be equal to log k plus log p par 1 by n, और 1 by n को पीछे ले लो तो 1 by n log p, right? तो slope यहाँ पे होगा 1 by n. Cool. That's it. Let's move on to the next idea, which is interestingly, mathematically speaking, at least very similar to what we have seen. ठीक है? Adsorption from the solution phase. यानी कि solution phase. अच्छा, अभी हम लोग बात कर रहे थे gas that goes on to a solid. अभी मैं बात करना चाहता हूँ solution में. यानी कि adsorbent solution में है या adsorbate solution में, कौन सी solution में होगा? हम लोग बात कर रहे हैं solids still being the adsorbent. यानी कि the surface still a solid. बट जो चीज अब्सॉर्ब हो रही है, अडसॉर्ब हो रही है, यानी कि अडसॉर्बेट, आई एम जस्ट एडिंग शॉर्ट, ये मैं बोल रहा हूं सॉल्यूशन से आ रहा है. सो नाउ इंस्टेड ऑफ अ गैस आई मे हैव सम सॉर्ट ऑफ अ सॉल्यूशन व्हिच हैज समथिंग मिक्स्ड इन इट, एंड लेट्स से टेक एन एग्जांपल ऑफ एसिटिक एसिड एंड वाटर. उसको चारकोल में डाल दो, तो चारकोल उसको अडसॉर्ब कर देगा. इस चीज पे जेई में काफी बार सवाल आ चुके हैं कि कंसंट्रेशन पता करो. नीट में आई थिंक स्ट्रिक्टली दिस मे नॉट बी द सिलेबस, बट हे एक छोटी सी बताने एक्सरसाइज, आई डोंट थिंक यू गोना इट्स गोना बी एनी हर्टफुल थिंग. इसमें न्यूमेरिकल्स नहीं आएंगे, बट इट्स गुड टू नो, राइट? सेम चीज हो रही है, एंड दिस इज प्रोबब्ली अ लॉट मोर रेलेवेंट टू यू एज डॉक्टर्स, राइट? यू गोना डील विद अ लॉट ऑफ सॉल्यूशंस, एंड इफ यू गोना डू समथिंग एडसॉर्प्शन इज मोस्ट लाइकली गोना बी समथिंग लाइक दिस, मोर देन अ गैस. ठीक है, आपके लिए. खैर, नाउ the concentration of the acid would decrease. Now, instead of pressure, we're going to talk about terms of concentration. That's the only difference. इसके अलावा mathematics exactly same है, ठीक है? तो I will take some acetic acid, shake it with charcoal, and थोड़ा सा absorb हो जाता है, concentration कम हो जाता है. इससे characteristics क्या होंगे? Very very similar to what we did. We're going to breeze through this very very quickly. तो अगर surface area बढ़ेगा, absorption बढ़ेगा. I'm assuming you're all sitting in class and you shout बढ़ेगा, सुनो ऐसे बढ़ेगा, ठीक है? And absorption कम होगा जब मैं टेम्परेचर बढ़ाता हूं, क्योंकि टेम्परेचर बढ़ाने से चीजें निकल जाती हैं, इवन इन दिस केस, राइट? एंड आई रिमेंबर कि गैस में क्यों होता था, क्योंकि गैस की वजह से पार्टिकल्स मूव फास्ट, मूव अपार्ट. हियर आल्सो दे गेट अ बिट ऑफ एनर्जी एंड दे मूव आउटसाइड. ठीक है, सिमिलर आइडिया. द मैकेनिज्म इज अ लिटिल कॉम्प्लिकेटेड बट द रिजल्ट इज द सेम. ठीक है, एंड द एक्सटेंट ऑफ एब्जॉर्प्शन डिपेंड्स ऑन द कंसंट्रेशन ऑफ सोल्यूट इन द सॉल्यूशन, सिमिलर टू प्रेशर, राइट? अगर प्रेशर ज्यादा है तो एब्जॉर्प्शन हो ही जाता था. इट वाज गुड एब्जॉर्प्शन. एंड नेचर ऑफ एब्जॉर्बेंट एंड एब्जॉर्बेट एज यूजुअल. तो ये 4 पॉइंट आपको लग रहा है बहुत सिमिलर है, राइट? एज टू व्हाट वी हैव डन बिफोर. एज आई एम नॉट स्पेंडिंग टू मच टाइम ऑन इट, आई एम अज्यूमिंग यू हैव सीन द लास्ट लेक्चर, एंड इफ यू हैवंट प्लीज को देख लेना. वी हैव डिस्कस्ड दिस एंड इन द फर्स्ट वन वी हैव डन दिस इन डिटेल. ठीक है, I can use the same isotherm, which is Freundlich isotherm. I told you we were just done with it, but छोटा सा पार्ट है बाकी है. पिक्चर थोड़ी सी अभी बाकी है with respect to Freundlich isotherm. Concentration को हम लेंगे instead of pressure. Everything else remains the same. That's why I really like maths, right? Maths doesn't discriminate. You put variables in, and if it mimics nature, why not use it? So instead of C, instead of P, I put in a C over here. Rest of it remains the same. The expression looks exactly like this, which means I can again take log on both sides. What do I get here? Log C and log K, and 1 by n log C, and yeah, that's it. Okay, I think if I have to do it in 2 steps, I apply the first property of logs, and the second property of log would be this. So, you're good, right? ये सब chill है? This is very straightforward. Do you want me to go slow on this? Let me know. I'm going a little quickly because I don't want to bore you. You've seen this so many times. Freundlich isotherm इतनी बार आप लोग सुन चुके हैं, and मैंने अभी just आपको दिखाया भी. If you want me to slow down, please tell me. Complicated सवाल Naruto. Complicated सवाल. Yeah. For now, I would say yes. But for solution things are a little bit complicated. ठीक है. For things that we are studying at this point, we can say that the behavior is similar. Okay. But the value of concentrations and the value of pressures are very different, right? जो pressure का value था, say it was 5 atmosphere there, and there's going to be no equivalent of concentration here. You can't say 5 atmosphere equal to 5 mole per liter, right? इसलिए things are a little bit complicated. So right now, with a pinch of salt, I'm going to say that yes, it does lie between 0 and 1. But the mechanism is a little bit complicated. Thanks for asking me that. If you want more material, I can give you material to read. I teach chem on Telegram, so ping me, I'll give you things to read. Most likely, they will be from either JD Lee or Zoomdal. Okay. Oh, surface chemistry, दोनों में नहीं है. The funny thing is, surface chemistry is not there in American books. I'm just going in a थोड़ा सा sideline जा रहा हूँ. American या फिर UK books में, usually when we do JEE advanced and anything else, we pick up these really good authors and we say यहाँ से पढ़ लो यार सब चीज़ है. Surface chemistry सिर्फ NCERT में और उसके बाद सीधे college में, ठीक है, if you decide to do engineering or something like that. Or obviously if you guys like doctors are going to do experiments in the lab. So surface chemistry NEET is your best bet. Anything more is just so advanced कि yeah, if you're open to the math, then it's understandable and easy. Otherwise थोड़ा सा tricky है, ठीक है? Okay. मैं तुमको घुमा नहीं रहा हूँ, मैं तुमको सच बता रहा हूँ. क्योंकि I've done chemical engineering and I've done the scary things that come along with this. Okay, they're very good when you know the math. ठीक है? Okay, but good question. Yeah. For now, yes. The short answer is yes. Yeah. So how do you know that this works? मैंने आपको बोल दिया. But how do you know this works? Just like in Freundlich isotherm, मैंने बताया था ना कि आप actual experiment में plots लोगे and you'll take a regression. You'll see कि अच्छा the line of best fit, the curve of best fit is approximately this, and इससे मुझे slope जो मिलता है, इससे जो intercept मिलता है, that agrees with literature जो मुझे मालूम है, जो बहुत मेधावी लोग कर चुके हैं, very very good people have already done this. Then you're like हाँ काम करता है, ठीक है? So if this happens, then you say yes, this works. Okay, that was a quick idea of how adsorption works in solutions and how Freundlich isotherm can be retrofitted into that. अब हम जाने वाले हैं deep into a lot of theory. So gear up. ठीक है. So what are the applications of all of this? मैंने आपको काफी theory पढ़ाई है. तो अगर कहीं पे से gases completely निकालनी है, तो here is the thing, right? It is extremely expensive, and you learn this in thermodynamics as well. कि हर किसी चीज को complete करना बहुत ही मुश्किल है. What I mean to say is कि I've got, say, this chamber here, and I want to remove all the air from it. I can remove most of the air, but the last bit of air is insanely hard to get rid of because the cost of vacuum just increases exponentially after you get to a point. Well, maybe you can get to 90, 95, 98, 99%, but the last 1% is going to be a big pain. But some places, for some things, if you want to make silicon, by the way, if you want to make silicon chips, you need very, very, very clear, clean environments. If you want to do that, how are you going to do that? So to produce something that's very high vacuum, मतलब पूरा gas निकालने के लिए, the remaining trace of air can be absorbed by charcoal, and this is a very simplistic picture. But this is what I'm going to do, right? मैं एक दो examples लेके आपको ठीक से समझाऊंगा, बाकी आप please NCERT से पढ़ लीजिए, because मेरा goal है कि आप में जागरूक करूं that interest to study, okay? Otherwise NCERT is hard to read, especially surface chemistry, because there's so much theory. एक line में एक चीज छुपी हुई है, और I'm pretty sure NEET में पूछा ही जाएगा उसमें से, ठीक है? Somewhere from the middle पूछा जाएगा. So this was one example of how adsorption is useful. Heterogeneous catalysis. This is probably the most important idea for us when we're learning organic chemistry. Yeah, this whole idea of the catalyst being a different phase, a different state than the reaction, मतलब कि ये heterogeneous catalyst हो गया. हम लोग डिटेल में इसी सेशन में इसमें बताएंगे. But solid can have a lot of surface area, उस पे गैस आ रही है, तो ये heterogeneous ही तो हो गया catalyst. Like for example, देखिए ये gas mask है. अगर आप किसी toxic environment में जा रहे हैं, which you may have to do, right? If you are in a place where there's some weird sort of an outbreak, these really good masks have these filters, and if you play these video games like Metro 2033 and stuff like that, you've got to replace the charcoal filter every time or you can't breathe because everything around is toxic. Very fun game. Don't play games, study, but So gas mask is a very good example of that sort of an environment, right? Where you use charcoal, activated charcoal to absorb gas. Yeah. Coal mines में use होता है. Yes, yes. Pro boy is asking me a question. Is there any limitation of front leak? हाँ, मैंने आपको 3 चीजें बताई, right? कि it fails at higher pressures and all of that. And those are the main limitations. I've just gone over those in the starting of the session. If you miss that, एक बार फिर से just watch that part again. ठीक है? This is also something I've told you. So what I've tried to do is the session is made in a way that a lot of things that we have taught before, the examples can be used here itself, right? It's not just SI. It has other stuff in it. It has oxygen. It has other stuff. So I'm not going to write the formula here because not that straightforward. It's a very big compound. ठीक है? Silica gel. मैं पूरा नाम ही लिख देता हूँ. Why be lazy? Silica gel. ताकि आप लोग गलती से लिखना दें कि यार SI डाला है उसमें डायरेक्टली सैंड हो जाता है. नहीं. Silica gel is used as a desiccant. मतलब it is used to because it has a very large surface area. Again वो पानी के molecules लेता है, humidity control करता है. ये आपके bags में होता है. When you buy a new bag from any of these cool brands या जूते में ये सब होता है ना कि do not eat. We've gone over this in the previous sessions, right? And there are multiple other uses. 3-4 चीजें और NCERT में दी है. Please पढ़ लीजिए, flashcards बनाइए. If you want, this is what helps me, right? Look up more about it, form a story in your head, and that helps you remember it. आपको बहुत मोटी मोटी किताबें पढ़नी है लाइफ में. Get used to it, starting right around now. Doctors of the future. ठीक है, अगला पार्ट. अब हम लोग बात करने वाले हैं कैटलिस्ट की. Now catalyst is the single most important part of this. It may not seem right now so because हम लोग अभी experiments lab में नहीं कर रहे हैं. But अगर आप lab में जाएंगे, these are industrially the single most important thing, okay, to make reactions happen. मत खेलो गेम्स यार. Yes, smoke filters by UKK. Yes, you learn some part of. Oh, you have. That's great, Pro Boy. Absolutely, you have. हम लोग वही चीजें को, there may be a little bit of repetition there, yeah. So a catalyst like say MnO2 specifically is used when I try and break down KClO3. Okay, KClO3 is a very interesting chemical. It breaks down and gives you oxygen, and oxygen can be used in very many things. Mostly as an oxidizing agent, I know, but also to burn things. Okay. So, but to do this, usually you need a very high temperature. If you just subtract 273 from this, there's about 600 degrees Celsius is the upper temperature. By using this catalyst, I can reduce that temperature, and the higher temperature or even the lower temperature goes down to 200 degrees Celsius. So, it's a big deal to lower temperature. High temperature मतलब high expense, बहुत ज़्यादा महंगा. कम temperature मतलब everyone's happy, especially industry. Now, I'll tell you where this is useful, right? Maybe not in your lab or in industry, but literally to make rocket fuel. And also Fuljadi and all of that. Well, not Fuljadi, but those fancy big rockets that you see on 4th of July celebrations TV में and all that. उन सब के लिए ये चीजें यूज होती हैं. ठीक है. Cool. Different types of catalyst. आप लोग already जानते हैं. Pro Boy ने बोला कि आप लोग काफी पढ़ चुके हैं इसके बारे में. तो if you want me to speed up, बताइएगा. Speed up in the terms, in the sense of कि cover things faster. मैं और जल्दी से बोलूँगा नहीं. I'll slow down if you want. The speed of my talking is not going to increase. But if you think that yeah, मालूम है, let me know. Give me a thumbs up saying I already know this and you know that you would like me to go on. ठीक है? काफी नहीं, थोड़ा. अरे मयूख नहीं यार. I'm here. जहाँ पे भी if you want me to repeat something, बताओ. We are here. ठीक है. So what are the different types of catalysts that we are going to look at, right? One is phases. मैंने आपको बताया था ना कि homogeneous. अरे आएगा. मैं क्यों इतनी अच्छी से handwriting आपको दिखाऊं जब beautiful slides बनी हुई हैं. No, my handwriting is horrible by the way. That's why I have these beautiful slides. So on the types of phases, यानी कि states, I can call them homogeneous या फिर heterogeneous. Homo means similar, hetero means different. तो अगर same phase में है तो homogeneous हो गया, अलग में तो heterogeneous हो गया. Impact of rate reaction, positive and negative. Positive makes sense, right? I don't want to speed up a reaction. But यार negative क्यों? In what planet would I say कि नहीं यार, slow it down? Why? Maybe कोई reaction इतना explosive था जो मैं नहीं चाहता हूँ explosive हो. और क्या हो सकता है? सोचिए, think about it when we cover that. तो ये थियोरी काफी डायरेक्ट है. इसमें मेन चीज है कि जस्ट रीड द क्वेश्चन केयरफुली, राइट? आपको देखते ही पता चल जाएगा कि कौन सा होमोजेनियस कैटलिस्ट है, कौन सा हेटेरोजेनियस. अगर तीनों में सब जगह जो है सेम रिएक्टेंट प्रोडक्ट और जो कंडीशंस हैं कैटलिस्ट, दे आर ऑल द सेम स्टेट, होमोजेनियस है. अगर एक भी अलग है तो हेटेरोजेनियस है. इस टाइप के सवाल आते हैं नीट में. ठीक है, कुछ आपको मैं एग्जांपल्स बताऊंगा और कुछ आप प्लीज पढ़ लीजिएगा. सबसे पॉपुलर एग्जांपल ये वाला है, हाइड्रोलिसिस ऑफ एस्टर. इससे बनता है एसिड और अल्कोहल. किसी को याद है ये रिएक्शन फ्रॉम ऑर्गेनिक केमिस्ट्री? प्यारा ऑर्गेनिक केमिस्ट्री. इसका किसी को मैकेनिज्म याद है? मैं डिटेल में नहीं जाऊंगा, बट बेसिकली द लोन पेयर ऑन ऑक्सीजन अटैक्स दिस गाय हियर okay, and it gets attached to this carbon here, and then magic happens. No, I'm just kidding. पहले HCl के साथ ये बन के H3O प्लस बनता है, ठीक है, और फिर ये जो है ऑक्सीजन ओवर हियर गोज हियर, ठीक है. अगर आपको ऑर्गेनिक में इंटरेस्ट है, प्लीज वेट फॉर इट टू कम ऑन, और इफ यू वांट टू चेक आउट लास्ट ईयर्स कंटेंट, यू कैन डू दैट. ऑर्गेनिक आने में थोड़ा समय है. वील हैव टू कवर. हे वेट, यू आर ऑल 12th स्टैंडर्ड स्टूडेंट्स. व्हाट एम आई सेइंग? यू नो दिस. You know this, याद है? Yeah. I just realized. I've looked back at the screen. I get confused. I was taking 11th grade class last. So yeah, आपको याद है? Okay, great. I won't go into detail. But yeah, beautiful things, right? I really appreciate the NCERT for this because they've taken the same reaction and taught it in multiple places ताकि आपको ज़्यादा चीज़ें ना याद करनी पड़े. So that's good, right? But then things become interesting. दूसरा एग्जाम्पल आपको बता रहा हूँ इसकी. यार SO2 और ऑक्सीजन दे रहे SO3. इसका तो कैटलिस्ट होता है वेनेडियम पेंटॉक्साइड. किसी को याद है क्या? ये आपने शायद पढ़ा नहीं होगा. मैं आपको अगले सेशन में पढ़ाने वाला हूँ ये. या हाउ मेनी एक्सपेक्टेड क्वेश्चन दिस चैप्टर? अभिनंदन विद द आई मीन लुक, एनीबडी हु टेल्स यू नंबर ऑफ एक्सपेक्टेड क्वेश्चन ना, तुम लोग को टेकिंग यू फॉर अ राइड. नीट की मर्जी यार, जितना डालेंगे एक या दो ही आएंगे. लाइक डू द मैथ, राइट? देयर आर 45 क्वेश्चन, देयर आर 30 चैप्टर्स अप्रॉक्सिमेटली. तो या तो एक आएगा या तो दो आएगा. इसमें से सवाल नहीं आने के चांसेस बहुत कम है, ठीक है. No, I can't tell you the structure of allene because we are not talking about that. ठीक है, XYZ. I don't mean to discourage you. I'm just saying you can look that up online, right? Let's focus on this. If you have any questions pertaining to surface chemistry, I will answer it right here and right now. ठीक है? Because this is a little bit of a jam-packed session. इसमें काफी theory है. Let's focus on this. Cool. Allene has double bonds here. Not discouraging you asking questions, but let's stick to this what we're talking about right now. ठीक है? But it's supposed to be vanadium pentoxide. ये क्यों लिखा है? देखिए, अलग अलग चीजों में अलग अलग टाइम पे दूसरे कैटलिस्ट वर यूज्ड, एंड राइट नाउ इंडस्ट्रियली मे बी वी आर यूजिंग वेनेडियम पेंटॉक्साइड, बट इन द फ्यूचर मे बी इट्स चीपर टू यूज नाइट्रोजन, नाइट्रिक ऑक्साइड. एंड हाउ डू यू नो? देयर वाज अ क्वेश्चन ऑन दिस, बाय द वे. आई एम नॉट गोइंग टू डिटेल, बट एक सवाल था कि हाउ डू यू नो दैट इस टाइप का रिएक्शन होता है. इन दिस केस द बिगेस्ट ड्रॉबैक इज, सिंस सब गैसेज हैं तो यार ये इसके साथ भी रिएक्ट कर सकता है, NO2 बना देता है. यार फिर कैटलिस्ट का फिर पॉइंट ही खराब हो गया, राइट? द कैटलिस्ट इज नॉट सपोज्ड टू रिएक्ट विद स्टफ यार. So, which is why we need to use some other catalyst. ठीक है? Small bit of an idea that I found to be very interesting. कि मैं इस reaction देखा कि यार मैंने I've always seen a different reaction. Interestingly, I can always also use platinum as a catalyst over here, and I can also use this. So why do you have so many different catalysts for the same reaction? Because the need could be different. Maybe lab made is cheaper to do this, but at the industrial scale, money doesn't matter. I have to make sure that reusability है. Cost is more important there, right? Think about these things. Think about these things. मयूक, एब्सोल्युटली, थैंक यू मयूक, एब्सोल्युटली. कॉन्टैक्ट प्रोसेस में ही ये सब V2O5 होता है, राइट? और अगर NO2 बन गया तो इसका क्या होगा? ब्राउन फ्यूम्स दिखेंगे. दैट इज द प्रूफ कि अरे ये हो रहा है. सो सी, माय सेशन इज गोना बी ऑल अबाउट दिस एक्स्ट्रा इन्फॉर्मेशन व्हेन देयर इज डायरेक्ट थ्योरी, बिकॉज थ्योरी तो आप डायरेक्टली NCERT से पढ़ भी सकते हैं, राइट? बट क्यों पढ़ेंगे आप? दैट्स व्हाई आई एम हियर टू मेक यू इंटरेस्टेड इन दैट. ओके, ग्रेट, कूल. So, by the way, ये पहला वाला is a pseudo first order reaction, if you remember that. छोटा सा information that I thought would be interesting to know. ये आपने kinetics में किया होगा शायद, क्योंकि पानी की quantity इतनी ज़्यादा होती है तो it does not really, it's practically कि उसकी concentration नहीं बदलती है. All right. Heterogeneous catalysis क्या होता है? The catalyst is a different medium from the others. That's all. It's as simple as that, right? इसके examples हैं. MnO2 आपने पहले भी देखा था दूसरी जगह. So it looks like all these D block elements act like catalyst. Think about this. ये हम लोग जब D block करेंगे उसमें आंसर होगा क्यों ऐसा होता है. Does anyone know why? Anyone wants to talk about it in the comments as to why is it that D block elements are everywhere? सोच के बताओ. Manganese, platinum. Well, nitrogen obviously D block नहीं है. NO was an exception. But yeah, it's very interesting, right? And this famous guy, that's why it's so highlighted, Haber's process. One of the most important things to the, because they say you could make explosives. With explosives you could blow up the earth. The earth matlab ki, zameen, and then you could build more buildings, dynamite, etc. And also fertilizers used everywhere. Now dynamite is used नहीं होता है. But iron is a solid in a catalyst over here. एक और चीज पूछनी थी मुझे, variable oxidation. Absolutely Mayuk, absolutely. Thank you Mayuk. Mayuk is on fire. Thank you. या बट इस रिएक्शन में कुछ मिस हो रहा है. आपको याद है कि मोलिब्डेनम भी था इधर, वो मैंने क्यों नहीं लिखा अभी? था कि नहीं? मोलिब्डेनम था कि नहीं? Naruto ji, absolutely right. एब्सोल्युटली राइट, वेकेंट डी ऑर्बिटल्स। मैंने लिखा नहीं मोलिब्डेनम, मोलिब्डेनम क्यों नहीं लिखा मैंने? शालिनी on fire, yes, absolutely, that's a promoter. That's the next thing we want to talk about. Before we talk about that, let's talk about the idea of what is a positive catalyst and what is a negative catalyst. और इसके just बाद, what Shalini said, I want to go with promoter. ठीक है? Mayuk, it's okay, don't retract your message. Let the chat be. It's okay, it's okay. Positive catalyst क्या होता है? जो एनर्जी बढ़ाता है, नहीं भाई साहब, जो एनर्जी कम करता है. Okay, positive मतलब it increases the rate of the reaction. Yeah? It lowers the energy barrier. Any bond that forms happens to lower the energy. But it does not mess with the overall lowering of energy. This is very interesting. It only lowers the activation energy. दूसरा कलर यूज करता हूं ताकि देखने में आसानी हो. Let's use a bright yellow here. ठीक है? मैं बस activation energy कम कर रहा हूं with the help of a positive catalyst. This guy right here, which is the actual, इतना बड़ा भी नहीं है. Hold on. This is the difference between, say delta H. So delta H does not change. Okay, activation energy changes. This you have studied in kinetics. I'm sure you have to start very well to you. So आपको मालूम ही होगा. तो positive catalyst lowers activation energy, and you're done. Negative catalyst क्या होगा? मैंने बोला था ना बहुत अजीब चीज है. Negative catalyst जरूरत क्यों होगी? Why would you need something called a negative catalyst? An inhibitor is basically something that increases the barrier. I told you, why would you want to do that? तो ये बढ़ गया, ठीक है? EA has increased. It would slow down the rate. मतलब some reaction is happening very quickly. यानी कि if reaction happen very quickly, that's basically a bomb. Maybe you don't want that. You want to control the reaction. Slow करना चाहते हैं, ठीक है? एक कारण वो हो सकता है. What is the other reason that you could have to have a negative catalyst? Think about it. Okay. सोचिए आप, and I'll give you another example as it comes to when it comes to promoters as well as poisons. Now, the difference between promoters and catalyst is a very small thing. I'll try and give you an example which is not strictly in the syllabus, but will help you understand. It'll help you understand at least कि यार फर्क क्या होता है. Why am I mugging two things called promoters and catalysts? दोनों तो मुझे सेम ही लग रहा है. We'll see. Catalyst की जरूरत है. बिना catalyst से कुछ नहीं होने वाला है. ठीक है? It's going to be very slow. But that promoter kind of aids the catalyst. Okay? Or promoters or inhibitor messes with the catalyst. Okay? I'll tell you in what way very quickly. So say in this case, I have nickel as a catalyst and copper as a promoter, ठीक है? And this is, what is this? ये डालडा बन रहा है. Vegetable घी नहीं है. घी तो सिर्फ होती है गाय की और भैंस की and all of that. This is डालडा, ठीक है? Very bad for your health. Molybdenum is a promoter over here. Somebody had pointed out, right? Shalini had pointed out. Extraction of intermediate state. Mayuk, sorry, what was that about? The intermediate state, are you talking about the mechanism? That we'll talk about in maybe when we do enzyme action, then we'll talk about the mechanism. Can you just tell me what you're talking about? I didn't understand that as such. Maybe it was negative catalyst. Okay, interesting. So now check this out. Beautifully shown idea. It's definitely not your syllabus, but it doesn't matter. ठीक है? देखो, सिर्फ निकल के साथ in this hydrogenation idea, right? This hydrogen comes onto this and it's good. But if I put molybdenum in here, and this is obviously an exaggerated idea, but this is theorized that the covalent bond gets weaker because, ठीक है, hydrogen gets stuck here, but because it kind of gets elongated. This is what a promoter does. Now, without the promoter, the reaction was still going to be faster than without any catalyst, right? But catalyst डाला अच्छा हुआ, promoter डाला और अच्छा हुआ. This is the proposed mechanism. Okay, way above NEET or anything you're ever going to learn in school, but for you to believe that promoter का कोई use होता है, ठीक है? Similarly, what does anti-catalyst do? Or a poison, yeah? Well, it poisons the catalyst itself. मतलब कि it decreases the activity. So instead of the reactant coming on to the catalyst and then reaction going ahead, ये भाई साहब हमारा जो negative catalyst है, sorry, negative, what were you calling it? Hold on, भूल गया. Anti, हाँ, poison या फिर anti catalyst है, वो खुद ही react कर जाता है. So basically यहाँ पे English थोड़ी सी लिखी है, text है from NCERT, so I'll read out. Preferential absorption of poison on the surface of the catalyst. इसका क्या मतलब हुआ कि reactant के बजाय you're saying कि भाई ये खुद ही आ जाएंगे. So this nice yellow colored, these balls are basically your poisons, and this is your nice red catalyst. Now instead of the reactant coming onto the surface, these guys come and deposit onto the surface, and because of that, catalyst gets deactivated. Again, not in your syllabus, but still good to know. ठीक है कि क्यों ये होता है और कैसा होता है. नाउ मोर इंपॉर्टेंट आइडिया कि व्हाई, ओके आई नो कि हाउ, बट व्हाई डू यू नीड अ एंटी कैटलिस्ट और पॉइजन? Some reactions, if they happen too quickly, you can't control them. And maybe you have some sort of a setup where, like, slow this down. I don't want this reaction to go that fast. You may have to increase the temperature to a certain amount or increase the pressure to a certain amount because industrially feasible why hai. But I don't want to go too fast because if it goes too fast it could blow up, right? Reactor design is a real thing. We are studying reactions on a piece of paper, but you have to physically make them happen in huge vessels. Okay, think about that. But अगर ये थोड़ा abstract लगता है, let's think of something that's closer to home, right? ये है क्या? Acyl chloride, okay? And this basically acyl ही है ना? Is that right? Yes, acyl chloride. Organic में, yeah. You react that with hydrogen, catalyst is PD, and then you see that BaSO4 is poison. And so much so that this chap got an entire reaction named after him, Rosenmund reduction. क्यों भाई? What's the big deal? If I did not do this, if I just use palladium, what is platinum? Palladium. Platinum and palladium ka mix, palladium. Anyway, palladium used as a catalyst maybe could reduce it all the way. It could maybe go all the way to an alcohol, or maybe it could go to an alkane. I don't know. Anything could happen, right? But I want to stop it at that point. So I poison its activity. ठीक है? So this is why an anti-catalyst or a catalytic poison is very useful when you comes to getting specific outcomes that you want. Okay? Any doubts, my good friends? एक quick सवाल पूछते हैं. If you have any doubts, marinate and ask me. Ames का सवाल. A catalyst changes the equilibrium constant, lowers activation energy, increases forward and backward reaction at different speeds, follows same mechanism for the reaction. I think you will know this one already क्योंकि आप ये kinetics में भी कर ही चुके होंगे. Right? Meda says B. Okay. Okay. Naruto also confident on B. So is Shalini and Decaf. Decaf is back. Deepu Ji is here as well. Okay. Everyone's saying B. All of you are right. All of you are right. Sure. Interestingly, it increases forward and backward reaction at equal speeds. If it did at different speeds, then by sab it would change the value of K. Right? What is K? K is K small kf by small kb. Capital K is equilibrium constant. ठीक है? और ये छोटा वाला क्या है? Rate constant of the forward and backward reaction. So it affects both the rates equally, right? Anyway, बाकी क्या था? Mechanism same है? नहीं, mechanism तो अलग है. That is the whole point. Mechanism अलग है तभी तो ये होता है. And it does not change the equilibrium constant. तो ये दोनों same चीज बोल रहे हैं. Yeah, all of you are right. Good job, good job. Amazing students. अगला सवाल. For not for any money. Where is Kaun Banya Crorepati? I haven't seen that in a long time. Amitabh Ji was really nice on that. Anyway, a catalyst does not alter the equilibrium constant of a reaction. The catalyst forms a complex with the reactants and provides an alternate path with lower energy of activation or the reaction. Oh, baapre. The forward and the backward reactions are affected to the same extent. Achha. Tanu Ji is saying B for the previous one. Mayuk is saying D for this one. Mayuk has changed answer to B. What is B? B saying ये दोनों सही है but they are not related. ठीक है. A saying कि दोनों सही है और they are related. C बोल रहा है क्या? C, you want to see C? C is the same. Assertion is correct, reason is incorrect. D is saying कि दोनों गलत है. Let's go back to this one. A, B, C, D. अच्छा, everyone is saying A, but कोई एक था जो ऊपर B बोल रहे थे. Yes, answer is A. कारण cause and effect. यार इतनी हिंदी आती नहीं. I'm trying. कारण और effect को क्या बोलते हैं हिंदी में? Anyway, बताओ मुझे. ठीक है. Never mind. So, look, it forms this complex and it does not alter, the forward and backward rate, and hence it does not affect the equilibrium constant. ठीक है. So I understand that somebody was saying B because उनको लग रहा था ठीक है दोनों चीज सही है पर related नहीं है. But related इसीलिए है प्रभाव हाँ हो सकता है प्रभाव. Good job. Thank you for helping me with the Hindi. I've stayed in Bangalore for most of my life here. तो although इलाहाबाद की roots इतनी हिंदी याद नहीं है. देखिए if both of these are same, इनका ratio the equilibrium constant होता है. Although हम लोग equilibrium constant को बहुत महत्वपूर्णता देते हैं, we say कि ये बहुत जरूरी है, but actually it's just a ratio of forward and backward rates, right? So in reality ये cause है और ये है इफेक्ट, राइट? इसीलिए मैं बोल रहा हूं कि दोनों रिलेटेड है। थोड़ा डिटेल में वो चलेगा, बट इट्स ओके यार, लेट्स फोकस ऑन दिस बिकॉज नीट इज ऑल अबाउट दैट वन एग्जाम। आई एम हियर टू टीच यू ऑल द थियोरी यू वांट, बट इट्स एक्सट्रीमली इंपॉर्टेंट टू बी एबल टू क्रैक दोज क्वेश्चंस। ओके, ठीक है, बट कैटलिस्ट ये सब मैंने बता दिया कि थियोरी है, ये होता है, वो होता है, बट हाउ डज इट फंक्शन? मैंने 2 जगह आपको डिटेल बताई जो सिलेबस में नहीं थी, अब हम बात करेंगे जो चीजें सिलेबस में हैं, ठीक है? ओके, एनी डाउट्स? आई हैव बीन ऑन अ रोल going all at it, but if you have any doubts, I'll pause for a second and tell me. Any questions, anything going on in your minds, anything you want me to talk about? Shall we continue? ज़्यादा हो गया? Are you okay? Give me some feedback on if it's all right. थोड़ा ज़्यादा जल्दी तो नहीं लग रहा है? ज़्यादा boring नहीं लग रहा है? Is the pace all right? Yeah? ये वाला पार्ट इंटरेस्टिंग है, बहुत इंटरेस्टिंग है। we've cut through the intense theory वाला पार्ट। आपको एनसीईआरटी पढ़ना पड़ेगा, उसमें थोड़ा और इंटेंस थियोरी है, मतलब इसमें जस्ट एग्जांपल्स हैं, राइट? ऐसे ही हेटेरोजेनियस कैटालिसिस के 3-4 एग्जांपल और हैं, होमोजेनियस के 3-4 एग्जांपल और हैं, और एग्जांपल्स ऑफ एडजॉर्प्शन के 3-4 और हैं। पढ़ लीजिए, फ्लैश कार्ड बना लीजिए, थोड़ा और पढ़ लीजिएगा विकिपीडिया और समवेयर एल्स एंड इट विल हेल्प यू। ओके, गुड टू नो, ठीक है। तो ये जो एडजॉर्प्शन कैसे हो रहा है, आई विल गिव यू द शॉर्ट आंसर, नोबडी नोज, बट लॉन्गर आंसर व्हाट वी आर गोइंग टू गो थ्रू नाउ, ठीक है? बिकॉज दिस नोबडी नोज के बारे में तो ग्रेविटी में ऐसे ही है यार, तो व्हाट यू स्टॉप स्टडीइंग ग्रेविटी और व्हाट? इट्स देयर, यू डोंट नो हाउ इट वर्क्स, बट यू गॉट टू यूज इट, राइट? सो let's go ahead and try to understand what work has been done on the adsorption theory for heterogeneous catalysis because that is industrially important. एक पुरानी थ्योरी थी, नई थ्योरी थी। नई थ्योरी हैज टू डू विद इंटरमीडिएट कंपाउंड फॉर्मेशन, जो अभी हमारे एक दोस्त बोल रहे थे, मयूख जी शायद ऊपर बोल रहे थे इसके बारे में, which I told him he will get back to later, right? What is the Purani theory? The old theory said that, okay, you've got all of them adsorbed on the solid catalyst, right? When we say heterogeneous, I'm assuming that my adsorbent is solid and the adsorbate could be either a gas or a liquid or anything else. ठीक है? तो liquid माने कि solution, solid या gas तो यहाँ पे है। adsorb हो गए, and अगर मैं concentration बढ़ाऊं तो बढ़ेगा, and अगर surface area बढ़ाऊं तो rate बढ़ेगा। ये 2 चीजें थी। और दूसरी चीज ये भी है कि ठीक है, अगर मैंने कॉन्सेंट्रेशन बढ़ाई तो ज्यादा आ गया, और वो जो एड्सॉर्प्शन होता है, रिमेंबर थर्मोडायनेमिक्स ऑफ एड्सॉर्प्शन, डेल्टा एच इक्वल टू नेगेटिव, और इससे जो हीट निकलती है तो दैट काइंड ऑफ एक्सेलरेट्स द रिएक्शन। ये थ्योरी थी, बहुत अच्छी सी नीटली टाइड इन थ्योरी। एंड अगर टेम्परेचर यानी कि हीट की वजह से टेम्परेचर बढ़ता है और हीट की वजह से टेम्परेचर बढ़ा तो रेट ऑफ रिएक्शन बढ़ गया। या यू आर ऑल ओके विद दैट, राइट? इररिस्पेक्टिव ऑफ वेदर एंडोथर्मिक हो या एक्सोथर्मिक हो, अगर मैंने गर्मी दी, if I give it heat, if I increase the temperature, then the rate of the reaction of all reactions will increase. This was the main idea behind the whole of kinetics, ठीक है? Anyway, ये पुरानी थ्योरी थी। नई थ्योरी काफी इंटरेस्टिंग है। ये बोलता है कि a catalyst forms temporary bonds, and a reason why we were able to study this because now we can literally see things at the atomic scale. Well, maybe not with binoculars, but with fancy equipment, yeah, with fancy equipment like transmission electron microscopes, okay, and SEMs and AFMs. They are very, very fancy instruments at research institutes across the globe. I'm sure AIMS has them, and so do all other fancy colleges like KMC, Manipal, yeah, I know that, VIT, not VIT, VIT is engineering, VMC, Vellore, and so on and so forth. Okay, Pondicherry, Jimmer. By the way, which colleges do you guys want to go to? I haven't asked you that. मैं आके सीधे आप लोगों को पढ़ाने लगा, हाई लो ज़्यादा बोला नहीं, because I thought that's what you guys wanted. But tell me, by the way, in the chat sometime, what college are you guys targeting? That would be interesting to know. Okay, it forms temporary bonds, okay, and it forms some sort of an intermediate complex. Why did I say intermediate complex? This has to do with d block elements, okay. They have a lot of vacant d orbitals, इसलिए वहां पे bonds form हो सकते हैं आसानी से, and that's why you've seen almost all catalysis happening with d block elements. Sure thing, आराम से do your thing Naruto, otherwise वीडियो तो बाद में है, आराम से आके देख सकते हैं. Doc for checkup. I hope you're all right, Naruto. I hope you're all right. मौसम अजीब है, please take care. What's the mechanism of this heterogeneous catalysis? Yeah, that's what you're going to try and look at. The main idea is that you have free valencies on the surface. ये आपको मैंने डिटेल में बताया था कि catalysis का basis है कि the surface atoms are different from the bulk. There are some dangling bonds or whatever you want to call it. कुछ free seats हैं वहाँ पे, and that's what makes those sites active, right? Okay. So here is a schematic. Yeah, NCERT may be diya hua hai. Here we have a little bit more elaborate way. So this is a catalyst bed. That's what these blue circles are. जिप में दीपू, wow, I like it. एक जगह बहुत गर्मी and दूसरी जगह भी बहुत ज़्यादा गर्मी with beach. Mayuk, AIIMS, JIPMER or SSKM? SSKM. I will check out what SSKM is. All right, great. Thanks. Keep telling me that. Yeah, while I explain, if you guys have some time, tell me what college you guys are targeting. So this is my catalyst bed, and here are my two reactants, right? Two different molecules, okay? Or maybe it could also be the same molecule combining. कुछ भी हो सकता है. Yeah, if I want to make a polymer, same molecules could combine. अलग भी हो सकता है. Let's just say that दो अलग-अलग molecule हैं. Could be the same compound or different compounds. Now these get attracted and come to the surface of this catalyst bed. ठीक है? यहाँ पे एक word diffusion लिखा था. Diffusion is just a fancy way of saying कि वहां पे कॉन्सेंट्रेशन ज्यादा है, मतलब इस तरफ इस कोने में ए और बी में, और कैटलिस्ट यहाँ पे कुछ नहीं है, तो जहां कॉन्सेंट्रेशन ज्यादा है उससे जहां कॉन्सेंट्रेशन लो है वहां पे चला जाता है. नॉर्मली डिफ्यूजन की बात एट आर लेवल इज विद गैसेस, इट कुड आल्सो हैपन इन लिक्विड्स, बट दैट्स व्हाट द वर्ड डिफ्यूजन मेंट, इफ दैट थ्रू यू ऑफ. ठीक है. नाउ दिस एब्जॉर्प्शन हैपेंस एट द सरफेस ऑफ द कैटलिस्ट, एंड आफ्टर दिस एब्जॉर्प्शन हैपेंस, देन a sort of an interesting bond forms between AB, and these bonds also remain formed. How can these bonds remain formed? Because remember, there are vacant d orbitals. Okay? Okay? And this is the intermediate where I've got everything. You've got the reaction you want, plus you've got these. So this intermediate is not very stable, because this compound would probably be happy with this. Like, can you imagine like carbon having more than 4 bonds? That's not possible, right? I'm not saying that that's what happens here, but hypothetically speaking, right? So this is good, but this is not very stable. This third step is not very stable. So after that, what happens is they break apart, they react, they form new molecules, and those new molecules again diffuse out. They get out, they evaporate, etc., and you get fresh reactant molecules. Again, can come back to the surface. So this way, the surface also kind of gets reused, right? And that's it. That's a small idea of this. So there is adsorption happening, then there is reaction happening with the different reactants, and there's a unstable intermediate step. Uske baad desorption happens. Desorption, remember, is just the same product that was formed. Now, jab ye desorption happens, tab ye bond break nahi hota, because the energy of desorption is much lower. The energy of desorption is much lower then this bond energy. Bond energy बहुत high होती है. Chemical bonds are 80 to 240 kilojoules, remember? And physical वाले तो बस 20-40 के आसपास थे. Very different. Everything in nature happens to lower the energy. Remember that. So path of least resistance, just like in physics and resistors and all that. Path of least energy is what happens here. ठीक है? Cool. And once this has happened, yeah, that's it. It goes away and you're happy, and there's more places for this. So if you want to see a nice visual of this, let's check out hydrogen gas being added to ethylene, which is another gas, in the presence of nickel catalyst. तो ये solid है और ये दोनों है gases. ठीक है? तो इनको देखते हैं यहाँ पे क्या होता है. Sit back and relax. So this right here is ethylene. एक double bond था. That's why I'm calling it ethylene and not ethane. And then look at that. This is what happens. Some hydrogen comes around there. The hydrogen molecule itself breaks. Atoms combine there, and there you go. You want to see that one more time? There you go. ये हाइड्रोजन टूटा, हाइड्रोजन का मॉलिक्यूल टूटा, and ये goes there. Pretty interesting, right? Pretty interesting. I'm pretty sure you'll be able to find such fascinating things online as well. But this was a brief idea of how the whole thing works. Okay? Yeah, Mayuk, absolutely, right? Beautiful. The media team here is just absolutely mind-blowing. Oh my God, I have just realized कि all this time ये वाला part covered था. I'm so sorry, guys. Such a beautiful animation, and बीच में मैं यहाँ पे हूँ बद्दा सा दिखाते हुए ये सब. But anyway. Cool. Now, the whole idea is that this modern adsorption theory, it explained how is it that the catalyst remains unchanged. Because see, in all of this, the catalyst को कुछ नहीं हुआ. Catalyst molecules are still like an army standing their ground. बाकी reactants आए, react करके चले गए. Which is interesting. That's what you see, right? And this works even in a very small quantity. तो बहुत छोटा सा catalyst का quantity लो, फिर भी because का surface area इतना ज़्यादा है, if you make very finely weighted things, even small quantities can have amazing effects, which is what we see. But the biggest thing where it fails is it does not explain the action of catalytic promoters and catalytic poisons. ये मैंने आपको एक्स्ट्रा जो बताया था ना, जो एनसीईआरटी में नहीं है, दो जगह बताई थी, वो क्या होता था, that I explained to you there. But this theory that's taught in the model absorption theory does not explain this. खैर, काफी थियोरी हो गई, काफी थियोरी हो गई. एक सवाल लेते हैं. Which of the following kinds of catalysis can be explained by the adsorption theory? थोड़ा सोचने वाला है ये, थोड़ा सोचने वाला है. बताइए. Oh, heterogeneous. Shalini, Mayuk, both saying heterogeneous. The next one is enzyme catalysis, homogeneous catalysis, and acid-base catalysis. Medha, TCAF. Excellent. You guys are so great. You guys are so great. Yeah, this is the right answer. So you may seem like the questions I'm asking you are very easy, but I've told you all of these are from the previous year papers. And that's the thing. While you're studying, ये सवाल बहुत आसान लगते हैं. The goal is to be able to remember these things as time passes, right? And the only way to do that is, well, you know, spaced repetition. बार-बार थोड़ा-थोड़ा पढ़ते रहिए. I know your plight. I understand आपको बहुत ज़्यादा पढ़ना पड़ता है. You have so much in bio, so much in chemistry, and you have so many numericals in physics. It's all hard. I understand that. So you have got to cut through the noise and पढ़ने के लिए अब एक बार समझ जाइए. ठीक से पढ़िए एक बार. उसमें थोड़ा टाइम लगेगा. Numericals और questions तो आराम से हो जाएंगे. Yeah, don't worry about that. The main thing is the theory. Okay? Yeah, absolutely. Yeah, pro boy. So I'm saying you got to separate these two activities. One is learning. The second is game mode. When I say game mode, I mean exam. You know, the thing that gives you a thrill ki bhai test hai. Separate it in the way you approach it. Not in the way that अरे you get 10th की exam है तो बड़ी चीज़ है. Not that. But rather exam है तो focus है सवाल solve करना. पढ़ना है तो focus है पढ़ाई करना, समझना. In detail समझना. ठीक है? Welcome back, Naruto. Cool. आगे बढ़ा जाए. Yeah? Let's look at solid catalyst in some more detail. We're going to look at some two very, very beautiful ideas. Yeah? And the first one there is the idea of activity. मतलब कि what is activity? Does it have anything to do with reactivity? In a way, right? The easiest thing to understand is how something affects the rate of a reaction. If it speeds up the rate of the reaction, then it increases the activity. If it slows down the speed of the reaction, then it decreases the activity. Selectivity का क्या मतलब है? Selectivity, मुझे येलो कलर पसंद है, ब्लू नहीं पसंद है, लाल पसंद है, काला नहीं पसंद है. Selectivity, just same things, me selecting different things. So just on that, if I change the catalyst, I get completely different products. Same reactants, different catalyst, different product. तो ये दो चीज हम लोग आगे देखने वाले हैं. छोटा सा आपको brief idea दे दिया, like a quick, you know, what's to follow kind of a thing. So this activity business, yeah, it affects the strength of chemisorption to a large extent. मतलब कि अगर मैं speed बढ़ाऊं reaction की, तो शायद bond बनेगा. अगर मैं speed इतनी slow कर दूं तो bond बनेगा ही नहीं. तो in chemisorption, this activity business is very, very important. ठीक है? That's why we say that finely divided charcoal has high activity. Because finely divided charcoal मतलब उसमें बहुत high surface area है, तो reactivity or activity is very high. Why? Because I want things to get absorbed on the surface. And if I get to do that, then the catalyst is said to be active. Okay? Because it has these sites that get filled and I can facilitate reactions to happen. But when I say activity, मैं ये नहीं चाहता हूँ कि जो reactants आए वो चिपक ही जाए यार catalyst पे. But that becomes a poison. You remember? I told you right कि poison क्या करता है कि instead of a reactant वहाँ जाके बैठ जाता है. And because of that, it's messed up. So again, this is like that Goldilocks zone. Not too hot, not too cold, just in the right place. Pro boy. Sorry, गला थोड़ा सा खराब है. Do I speak Kannada? Swalpa Guddu? Yeah, I've been here a long time, but the people in Bangalore are so nice that, you know, they make do with English and Hindi. Yeah, but Kannada is a great language. I lived in Bangalore, by the way. I also speak a little bit of Tulu, by the way. Amazing language. Khair. So here is an example of two different things, the blue one and the green one, right? In the blue one, you notice that things are going and sticking around. In the green one, as soon as they go there, some reaction, some chemicals are formed and they leave right away. So it's very clear that the green one has a high activity because the products that are formed, they get desorbed easily. So in this chap here, desorption is quick. In this is also facilitating the reaction. But the problem is कि एक बार वो products बन गए, once these get formed, they're not leaving the spot. So, you know, like politicians standing on the SC is really, really tight. You don't want that in a catalyst. If that happens, it's not a good catalyst. But so here on this side, there's high activity. Very easy thing, but I just thought I'll show you through. Green is a better catalyst, exactly. Get a bit of water, sorry. This part I really like. ये part मुझे बहुत अच्छा है. Yeah, Tanu, exactly. This option for whatever reason was not happening. Yeah. For hydrogenation. अब ये मजा आएगा, ठीक है आपको. Beautiful diagrams and also very interesting. Theory ये है कि catalytic activity increases from group 5 to group 11 metals. अभी what is group 5? What is group 11? Do you remember? I'll get to that. Don't worry. Maximum activity is shown group 7 to 9. One more theory point. ठीक है, देखते हैं. So this reaction, just water being formed, by the way, takes electricity. That's how much energy this reaction needs. But I can kind of make it faster if I put platinum there, right? Electrode, etc., etc. Why platinum? Nickel, palladium, platinum are all great catalysts. Platinum is in the 10th group. ठीक है? Group मतलब these guys. I hope I counted right. So where were these guys? Nickel, I found nickel. बाकी कहाँ गया? Help me out a little bit. Where's platinum, guys? Here's platinum. Cobalt यहाँ पे है. But I was going to look at nickel, this guy, and what is the third one? Copper is also here. Zinc is also great, but I think zinc is usually used with ZNO. Chromium also is here. Molybdenum also is here. You see, all these guys that you've been studying, palladium भी यहीं पे, palladium भी यहीं है. They're all, yeah, look at that, look at that. All of you are so great. They're all D block elements, right? They're all D block elements. By the way, I got this from this site. It's the best site. Oh, I should learn how to spell. This is the best site I have found for the periodic table. The most beautiful thing. I wish I had this when I was a kid. Yeah, most beautiful thing of anything related to the periodic table. If you're studying chemistry, get a periodic table. And this is it, the one online. Amazing. So now let's understand that based on which catalyst I take, I will get different reactions. Okay? So the same thing, I'm going to take maybe just one simple example. Yeah, two very, very straightforward, simple molecules. And they're going to give you very, very different products based on different catalyst. Okay, so what this is doing is the catalyst is directing a reaction depending on just what surface is being used. Okay, so let's see. Pehla wala, right? I've got nickel surface. This is what my amazing thumbnail was about. So our great creative person, Shavri, said that, you know, your poses are really boring. I need some better poses. So I went and did that. I don't know, I'm not very new to YouTube. Like, you know, do something like this. And then they made this nice thumbnail. Short story about the thumbnail. Anyway, so you've got these two things. You've got carbon monoxide and hydrogen, right? And they react on nickel surface all the way to give you methane gas as well as water. Okay. Now if I change this catalyst to something else, you want to guess what this is? I change it to copper. I get formaldehyde. What is formaldehyde? What use does formaldehyde have as a NEET student or as a aspiring doctor? It's used to preserve specimens in your lab, right? The smell that you get in a bio lab. I remember, I don't know if it's still legal or not, but back when I was in school, it was a little scary, but people would dissect frogs. I'm sure you dissect more things than just frogs right now in actual medical school. Preservation of specimens, exactly, yeah. So, at copper when you use a copper surface, with the same reactants, you get formaldehyde. And this is where I want to show you this amazing meme that I got from this place on Reddit. But yeah, that's funny. I found it to be very funny. I'm sorry, I had to do that. Casualdehyde and formaldehyde. So formaldehyde, ये formula है. Please don't ever forget it. It's a very, very useful industrial chemical. Let's move on. I had to make that. I had to do that. I could not. I was like, but anyway, yeah. Now if I change the catalyst to zinc oxide surface along with copper and CrO, Cr2O3, then I get this guy here, methanol. So it's very interesting, right? I have different beds of catalyst and I get different products. So they're directing a reaction to completion. Okay. So yeah, that was it about selectivity. Now, this is a very, very cool thing in organic synthesis, and organic synthesis can get very complicated. मैंने तो आपको बहुत छोटा सा दिखाया. There is this idea of chirality being preserved, and you know this better than I do. Most biomolecular reactions have huge things, and if I get one R version or S version, one could be a poison, other one could be, you know, like a life-saving drug. The Alzheimer's protein that was recently discovered, you know, something that unfolds the Alzheimer's protein was a chiral compound. So it's pretty interesting. Yeah. Different can give completely different products. So it's very, very useful in pharmaceutical industry, organic reactions, all of that. Maybe some of you will go on to do B Pharma. Anyway, can the shape and structure of a catalyst also affect the catalytic reaction? अगर मैं इतने प्यार से आपसे सवाल पूछ रहा हूं, then the answer is yes, a resounding yes. Just stick around. I know it's been exactly an hour, but we'll just take 2-3 more minutes and we'll wrap this up. Very interesting part. Shape selective catalysis. यानी कि I can literally trap molecules of particular shape and size inside a bigger molecule. It's crazy. This one blows my mind away. Okay. So I have a huge cage-like structure which has pores, or you know, the cage in between, and that is perfectly sized for the reactant, yeah, which is crazy, reactant or product. Such things are known as zeolites. Look at that name, it's so heavy. Zeolite sounds so cool to say it. Anyway, they are shape selective catalysts because of their honeycomb-like structures. This is honeycomb. Scientists really like giving these kind of names to it, right? It does not look like an actual honeycomb in any way, but yeah, sure. Zeolite physically ऐसा दिखता है. At the molecular level, it looks like this. Now these pores, they are the honeycomb-like structures. इसमें आपको 3 type के molecule दिख रहे हैं, right? There's this gray one, there's this red one, and then there's this weird pink one. Okay, we'll look at what is what. So these zeolites are made of 3 different things, right? They are 3D networks of silicates. Silicates यानी कि SiO-Si bonds. Now in that, some of those Si bonds are replaced with aluminium. So ये aluminium are these pink ones. This is silicon and this is oxygen. ठीक है? So you get this amazing framework, and because of aluminum in the mix, it gives this amazing pore size. So depending on, you can actually create these for different pore sizes. Very expensive, so you need very small quantities to make this work. So generally for these set of zeolites, this is the pore size you get. So if a molecule, this is where it gets really cool, right? Cisplatin and transplatin. Thanks, ProBoy. Thank you for that input. So you have organic molecules of different shapes and sizes. So this chap's not going to fit. This chap's going to go through just fine. This is what is a shape selective catalysis. Yeah, that's it. Okay. The best use of zeolite is in the cracking of a hydrocarbon and isomerization. What is cracking of a hydrocarbon? Let me use a color that you'll be able to see. Hydrocarbons are, you know, whatever, CXH, whatever, CN. So I write something similar to you, 2N plus 2. Yeah, this is a alkane. So you have a large one like naphthalene, and you break that down to gasoline or petrol, or you break down further to methane gas, right? That is what cracking is. Isomerization, sorry, not isomerism. What did I say? Isomerization, right? So anyway, this catalyst ZSM5 converts alcohol directly into gasoline. Oh, that's interesting. Okay, by dehydrating it to give a mixture of hydrocarbons. Oh, and this actually has been patented by a company. You may have heard of this little known company, only the first probably in Fortune 500 companies. There's a company called ExxonMobil. पहले अलग-अलग होते थे, तो Mobil has patented this. There's a process called MTG, which is methanol to gasoline. Gasoline मतलब petrol, ठीक है? American लोग gasoline बोलते हैं, हम लोग petrol बोलते हैं. And you know what? How does this work? Essentially, all organic reactions are acid-base reactions in the terms of Lewis acid and Lewis base theory. ठीक है? Yes, refining of petroleum, but वहाँ पे तो यूज होता है और ये दूसरा यूज है, ठीक है? Okay, great. With that, we are done. Apologies for the 5 minutes extra, and thank you for sticking around. I'll do a quick recap of everything we have done. Homework questions आप ले लीजिए. Here's the first one. Straightforward है. Take a screenshot or come back and watch it and give me the answer to this one. And I have, oh no, is that cool? Oh no, what's happening? Homework is oh no. 2 सवाल हैं, कर लो please. बहुत simple सवाल है. और तो एम्स का भी सवाल है. एम्स जाना था आप लोगों को. ये वाला भी कर लीजिएगा and tell me what you think about it. Okay, session summary, quick idea. The biggest drawback, somebody had asked me initially, right? It works for a limited range, but at high pressure, Freundlich isotherm does not work. And it only works for a unimolecular layer of the adsorbent surface. And I told you that multiple layer में क्या होता है मैंने आपको approximately draw करके बता दिया था, right? And a similar thing could happen when you have a solution phase. The example was, acetic acid in water shaken with charcoal, and the equation I get is exactly the same. Instead of pressure, I talk about concentration. Slope क्या था इधर 1/n, intercept था log k, right? यही था. और yeah, same चीज मैं यहाँ पे कर सकता हूँ. I'm quickly going over this. Catalyst क्या था? You know this already. Providing an alternate pathway does not affect the equilibrium constant, affects the rate of forward and backward reaction. These are different types of catalyst. Homogeneous, heterogeneous, positive, negative, blah blah. ये तो हमने अभी ही किया है, बहुत डिटेल में किया है. ठीक है. Heterogeneous मतलब अलग phases, homogeneous मतलब same phase. Positive catalyst यानी कि EA कम करना, और negative catalyst यानी कि EA बढ़ाना. And I told you as to why you'd want to do it. Yeah, promoter is something that doesn't get affected itself, but kind of aids the catalyst. I gave you examples, and also that beautiful thing where the hydrogen bonds get elongated because of molybdenum. Yeah, nickel and molybdenum के साथ. And the poison का भी idea था कि अच्छा वो तो खुद ही react कर जाता है on the surfaces, hence it messes with the catalyst. And the adsorption theory हमने अभी detail में किया. I will not talk about it. I'm just going to leave it on this. If you want to take screenshots, you can. If you want me to explain anything, please tell me. Okay, I'm not going quickly or anything just because time. I have all the time in the world. I'm going quickly because I value your time, and I've explained this just now. अगर कुछ आपके पास doubts है, please tell me. I will explain. Okay, we've just gone over the mechanism of heterogeneous catalysis in great detail. Yeah, and yeah, with that I'm pretty much done. I spoke about activity and selectivity right at the end, and I told you that okay, why it's the last group D block elements that are most important. I gave you 10th, although it says 7 to 9 are maximum activity, but the most used ones are still the 10th ones, which is palladium, nickel, and not nickel, sorry, palladium, zinc, and what's this other guy called? Platinum. Yeah, zinc was 12. Anyway, we did that in detail. Selectivity ke baare mein, you saw these nice animations and all going on, and that's it. Last part was zeolites. Cool. With that, we are done. Any doubts? Anything else? Nickel. Yeah, nickel, palladium, and platinum. Cool. Anything else, guys? I know your session thoda sa zyada jam-packed tha, but I wanted to make it a little bit exciting for you. I gave you a little bit of extra information way over and above NEET. I hope you liked it. Check out the homework questions. Tomorrow we'll meet for 11th grade gaseous state. And Shamko, I think today at 7, Ankita ji is going to be doing her bio session. Yeah? Okay. It was very nice to be doing this with you all. I'll see you around. Bye-bye. Bye. All right, most welcome.